Hello there, we've got another A-level maths video for you here. This is Statistics Year 1. We've moved into Chapter 2, Section 2.1, and we're going to be reminding ourselves about things like means, medians, and modes. Now, I'm sure you've seen these things before, so why don't you remind yourself how they work by having a go at the question on the screen, pause the video and restart once you've got your answers. Okay, let's quickly just check that we know what these things are about. So the mode is going to be the item of data in our set which appears most often. Now here we've got 26 occurrences of the number 2 in our set of data, and none of the other numbers appear as many as 26 times, so therefore our mode is going to be 2. The median. Now the median is the number which appears halfway through our list if we were to put them all in order. So if we imagine our 11 zeros followed by our 18 ones, followed by our 26 twos, and so on, we would find that the middle number would actually be a 2. And that's because we have 100 numbers in our set of data, and the 50th and the 51st numbers would both be 2s. So therefore our median is also equal to 2. Okay, and finally the mean. Now the mean is the one where we add together all of our numbers in our set of data and then divide by how many there are. So if we add together all of our numbers, we have 11 lots of the number 0, so 11 times 0, plus 18 lots of the number 1, plus 26 lots of the number 2, plus 23 lots of the number 3, plus 15 lots of the number 4, plus 7 lots of the number 5. Okay, and if we add all that up, I think we get the answer 234. But then we've got to divide by how many items of data we've got in our set. Well, we're told in the question there's 100, but if we wanted to confirm that, we could just add together the 11 plus the 18 plus the 26 plus the 23 plus the 15 plus the 7, and we do get 100. So our mean is going to be 234 divided by 100, which is 2.34. So nothing you haven't done before, I hope. Now, here's something that you may not have been aware of, though, is that we've got some technical words which describe these things. So the mean, the mode, the median, they're all single values which in some sense try to represent a typical or an average value from the set of data it's come from. And these are examples of things called measures of location. We're going to be looking at a lot more measures of location later in the chapter. But when we have measures of location which do try to give an average value for the set, those are sometimes called measures of central tendency. And one of the things that we need to be able to do with these various different types of average or different types of central tendency measures is work out which ones are appropriate for particular situations. Please have a think about the question which is on the screen. Pause the video, read it through, and have a think about what's up there. Why is the median probably a better measure of central tendency to use in this situation than the mean? So what did you think then here? Well, you probably noticed quite quickly that there's a very unusual item of data. That 19 doesn't really fit the pattern of the main data here. So that's going to heavily affect the mean, but it's not really going to affect the median at all. So you could argue that the median is a better at giving a typical value for this set of data because of that unusual 19 value, which really kind of heavily affects and distorts the mean and means that that number of 5.4 for the mean is not really kind of representing a typical number from that set anymore. Does that make sense? And this is going to be something that you're going to need to be able to do yourself, is to identify and describe why particular measures are better than other measures for particular situations. Okay, let's move on. We've got a bit more formal notation that we need to learn here. Now, you may not be aware of some of the things which are on this screen, so I'm going to go through them here. Now, in statistics, we use the following conventions. When we see a variable, such as x, that doesn't necessarily represent just a single value like it might do in other branches of mathematics. Instead, in statistics, it often represents multiple values of all numbers in a set of data. So for example, if I were to look at the heights of let me say that again, the heights of all the people in the room that I'm in, then I might actually sort of call all of those values x values, because x represents the height of the people. Does that make sense? Okay, next line down, you can see there's a weird looking symbol. Some of you may have seen that before, others may not have done. Looks a bit like a letter E, but it's not a letter E. It's actually a Greek letter sigma. And when we see that, it means we need to find the sum of what's coming after it, or add some stuff up. The symbol n in statistics pretty much always represents the number of items we've got in our set of data. And the symbol x with a bar above it is the symbol we use to represent the mean of the set of x values. And if you want to say that out loud, we do just say x bar. Okay. So putting that into a formula for x bar, the mean, it's always given by the sum of the set of data, so sigma x, divided by the number of items of data we got, which we always use the symbol n. And you'll need to get used to using these symbols and recognize them when you see them here. So let's just start off with that here. Question on the screen for a set of data that I've got there. Can you determine the values of n, the sigma x, which of course is the sum of the x values, and then x bar? Okay, let's see what we've got here then. So n, do you remember what that was? It's the number of items of data we've got in our set of data. And here, I think we've got 10 items of data, so therefore n would equal 10. The sigma x. Now the sigma, of course, just means add together a bunch of stuff, so the sum of. And then x here, the x values are all of the different values in our set of data here. So adding together all of those x values, we get 63 plus 65 plus 67 plus 68 plus 69, all the way up. Okay, let me write them all down. 72 plus 74 plus 75. And then when we add that lot up, you should get the answer 694. So our sigma x, our sum of our data values here, sum of the x's, is 694. And then finally, x bar. That just means the mean of the set of data. That's given by the sum of them all divided by how many there are. So in this particular case, 694 divided by 10 gives us 69.4. Okay, one other situation which I want to make sure we look at in this video, which is when we've got data which is in a grouped frequency table. Now, we looked at grouped frequency tables a little bit in an earlier video, but we need to be able to kind of work with data which is given to us in this form. So this particular group of data, or this set of data, deals with speeds of vehicles as they pass a particular point on a motorway. And you'll notice that the data has been rounded. So you might notice here that there are some, there's a gap here between the 58 miles per hour and the 59 miles per hour. And between the 61 and 62. So that means that obviously these data have been rounded to the nearest whole number. So first of all, I think the first thing I'm just going to put down here are the actual class boundaries. Remember, we talked about these in a previous video. So the 56 to 58, because this number 56 is a rounded number, it actually means that any value which is greater than 55.5 might round to the 56 here. And then the upper class boundary here would be 58.5. Yeah, so hopefully you remember that from previous work we've done. And let me just fill in the other class boundaries here. So we've got all those there, right? And that's 70.5, 73.5, and then the one up here, 76.5. So even though the data is presented us in this way, we need to be aware that these are the actual class boundaries that we're dealing with here. Now, let's see if we can actually deal with finding an estimate for the mean of the speed of these vehicles. And notice that it says that we are going for an estimate here. Why is it that we can't actually find an exact value for the mean here? Well, the reason is because the 4 vehicles here, for example, we don't know the actual speeds of those vehicles. All we know is that we're somewhere between 55.5 and 58.5. So they could have all been sort of quite low in that range, or maybe a bit higher in that range. We don't know. Similarly, all of the other classes here, we don't know the actual data values here. All we know is that there were 12 items of data somewhere between these numbers, 28 items of data somewhere between these numbers, and so on. So there's no way we're going to be able to work out the precise mean of the speeds of these vehicles. We're going to have to do an estimate, and we do an estimate by looking at the midpoints of each of these classes. So the 4 items of data, which are somewhere between 55.5 and 58.5, what we're going to do is we're going to take the midpoint of that class, which happens to be 57, and we're going to say that those 4 items of data are going to be pretty much close to 57, and so therefore we'll just kind of use 57 for all 4, and that's not going to give us an exact answer, but it is going to give us a good estimate. So let's fill in the other midpoints here. Okay, you can check those if you need to. Okay then, so let's see if we can now work out the mean of the data here. So we'll use our notation here. We'll use x bar to be the mean. And the mean here is going to be given by the sum of all of our items of data divided by how many items of data we've got. Now, how are we going to calculate those? Well, adding together all of our items of data, we're saying that we've got 57 here, but that's happening 4 times. So basically I need to multiply this number 4, which is the frequency, let's call it f, by the 57, which is the actual data that we're going to use, which we'll call that x. So we need to multiply f by x and then add together all of those things. So here, the 4 times the 57, and then add that to the 12 times the 60. Can you see the f times the f times the x, adding all of those things together once we've worked that out. And then the n here, well, we're going to have to work that out just by adding together all of these frequencies. This tells us how many numbers we have in our set. So I could write here the sum of the f's. Okay, so here's an alternative version of our formula, if you like, for calculating a mean, once we've got a frequency table or a grouped frequency table. Now, I'll spare you the details of the calculations. I'll just tell you that when I did this earlier on, adding together all of the items of data, I got the answer 11,622. And then how many items of data do we have? Adding together all of these numbers in this frequency row, it becomes 174. So therefore we end up with a mean of 66.8, which has been rounded to 1 decimal place there. And that's the kind of thing which, again, I expect some of you will have seen that sort of thing before. Some of you will be experts at it already. But let's just see if you can make sure that you can do this yourself. Don't forget to think about those class boundaries, those midpoints. See if you can do the whole thing here. Try and use the correct notation if you can, and have a go at the question on the screen. Restart once you've got your answer. Here we go then with the answer to this one. So again, I'm not going to put down all of the details here, but what you should have got when you added together all of your numbers, so multiply the frequencies by the midpoints, so frequency by midpoint, add them all up. I think when you do that, you get the answer 825. Okay, then the number of items of data we've got in our set, which is just adding together the frequencies, there happens to be 40. And so our mean going to be given by 825 divided by 40, which is 20.625. You may have rounded that to 20.6. That's absolutely fine. And so there are our calculations. Now, finally, it also asks you to explain why your answer is an estimate. Well, of course, that's exactly the same reason as in our previous example. It's because the numbers have been grouped together. We don't have the exact length of these runner bean pods. All we know is we've got sort of approximate lengths for each one. So therefore, that means that answer here is an estimate and it's not exact. And there we go for this video. I would imagine that quite a lot of that is stuff you've seen before. Maybe some of the formal notation and the sigma and all of that kind of stuff might be new to you. But if you want to get a bit more practice, exercise 2A and 2B in the textbook is where to go. And I'll see you again next time.